80 meters, seam thickness is 9.6 meter, extraction height is 3 meters, and immediate roof is coal and sail. And and immediate roof is the most important condition in the design of support. So this is the way investigation was conducted. Investigations were conducted at the mine to understand the geomechanical behavior of the strata in the gate roads and in the face. These investigations were aimed at measuring the location and magnitude of the front abutment and deformation of the strata surrounding the gate roads ahead of the longwall face. These parameters were measured using geotechnical instruments such as vibrating wire stress capsules, magnetic ring boreholes extensometer, strain bars, telltale extensometer, load cells, and convergence point. The location of these instruments uh, these are the location of the instruments which were placed. So we black circled out which we are seeing, those are the load cells. And these 5 instruments were used: load cells, convergence station, telltale extensometer, stress capsule, and strain bars. And this is the way it is located at the gate roads. And so in the given diagram, we can see that L is for the load cell, C is for the convergence station, and on the left hand side, you can see that at how much distance it is located. So on the left hand side, we have the barrier. And similarly, on the right side also, we have the barrier and tailgate. And on the also on the right hand side, we have the main gate. On the left hand side, we have the tailgate. And we can see that on the main gates, convergence station are located. So these are C23, 22, 21. These are the station numbers. And we can now see that what has happened to the GOP when the phase advanced. So when the phase advanced, we can see that the GOF span is increasing. So this is about the how instruments were located in the gate road. So gate road convergence. Convergence stations were installed at 10-meter interval from the face in the gate roads. 23 convergence stations from starting from C1 to C23 were installed and monitored for understanding the convergence of the roof to floor in the gate roadways. The maximum convergence within 10 meters from the face was an average of 20 mm in the tailgate, while it was 15 mm in the main gate. So this is the where we can see the maximum convergence. It is the means convergence distance, and this is the distance from the gate road. So this is rate of convergence, which was used in the equation to uh, to measure it, and this is the most important thing, and it is most difficult to calculate. So stress variation. Three straight capsules were installed in the panel to understand the change in stress during extraction of coal. These stress capsules were installed at 140-meter and 170-meter position in the tailgate at about 5.4 meter into the block, while the other was in the barrier at 170-meter in the main gate at about 5.4 meter laterally into the barrier pillar. The intensity of abatement loading is found to be negligible, with a variation of about 0.5 kg per centimeter square stress at 140 meter in the tailgate. These values indicate that abutment loading is not the readings were supported by the physical observation of intact sides of the gate roads without any precipitable stalling. Variation in the stress during extraction of coal in the longwall panel. So this diagram is showing how the variation in stress during extraction of coal in a typical longwall panel. So on the x-axis we are having the elapsed time days, means we are having the days, and how we can see how it is progressing from 11th September to 26th October. So now we are having the CP1 for today. So today's CP question is, what instrument students have seen and their experiences with its installation and monitoring. So now is the time for CP1. Those who want to answer it can answer it now. Okay, sir. And in the meantime, sir is taking attendance. Yes, sir. Okay, sir. Let me pass. Yes, sir. Now you speak, sir.
Okay, my beloved students, should be highly thankful to our Nikhil for sharing his mobile to hear my voice and whatever I wanted to say. To him I am telling, so that you should have a solution to any type of problem. Don't worry, now if you have any have taken attendance after this CEP. So this is not only you giving for getting good marks, but it is information to others also about the practical observations, whatever are practical experiences what you have, you are sharing with them. That should be the spirit behind giving your answer or information to all our beloved students. Okay, anybody?
Uh, Hello, sir.
Yes, continue. Continue.
Sir, Rohit Kumar, sir.
Very good. Now Ravi is giving his answer. Ravi Kumar.
Sir, Rohit Kumar,
Yes.
sir.
Ravi
Sir,
Kumar.
Rohit, sir,
sir,
Rohit.
Rohit Kumar.
Continue, Ravi. Yes. Continue,
Sir,
Ravi.
actually, I have seen an very basic method of measuring the strata, sir. It doesn't include any instrument. It's hello,
Continue. Yes, continue.
sir. It doesn't include any instrument. Actually, they just uh, tie a very tight knot between both the surfaces, the surface and the immediate roof, and they left that for 1 month, 2 month, or 6 months, and after 6 months they come to that area and see how much the string has loosened.
Anybody else want to give their experiences? I can tell on my view. If my voice is echo, Nikhil will be telling about what I want.
Anyone else want to answer the CP question?
I know some of our students who are there with me conducting investigation. For example, I think our Robin, Hitesh, Mohit, and remember others. There were Pandav, 5 students from there. I think it's a little bit echo in between. I can also say something between. Very good. Now, Nitesh, are you present here?
Nitesh.
Yes, sir.
Then you share your experience. You are there with me, along with me in GDC 11 incline. It need not be
Yes,
long
sir.
one.
Yes, sir.
That's why I made it general. Your experiences, whatever instrument you have seen, that is for information to us.
Sir, for the monitoring, we are using dual height tailtips at various location junctions and galleries in the same, and also convergence rods, load cells, and these are the major instruments they are using there, sir.
Are you seeing the data?
Yes, sir.
And how much it was observed, how much convergence, how much load on that. Then we will continue our class. Whatever you could remember. Okay, don't worry. Now we
Sir,
will
I don't
go ahead.
remember the data actually, sir. But
Okay.
I have the variation data what I have done.
That's what I wanted through you.
Nitesh, sir is asking you to share the variation of data you were talking about.
problem. We'll continue.
Nitesh?
Okay, now we'll continue. Are you able to see the slide now and make it a little bit bigger?
Yes, yes.
Now you can see.
So now we are going to talk about load on supports in gate roads. Open circuit hydraulic props of 40-ton capacity were installed in the gate roads at a maximum 9-ton setting loads. Maximum load on a hydraulic prop reached up to 8.7 tons within 10 meters from the face. Maximum change in the load of the hydraulic prop was about 2 tons in the main gate. Average load on the hydraulic props remained within 8 tons in the gate roads. Okay, CP2 question is why setting load is required. So now we are moving on to strain. Three strain bars were installed at 100 meter and 140 meter in the tailgate and at 140 meter in the main gate to estimate the vertical strain over the coal pillar ahead of the cutting face. Up to a face advance of 100 meter, strain was not precipitable over the pillar. Perceptible, sorry. However, the strain bar at 140 meter in the tailgate indicated a compressive vertical strain of 2 mm per meter at 110 meter and 10 mm per meter at 130 meter face advance. Strain bar at 140 meter in the main gate indicated tensile strain of 4 mm per meter at 105 meter face advances and 1.5 mm per meter of tensile and successive compressive strain at 125 meter face advance. And so these two figures are showing how the figure changed on the power supports. And so these are for the rear legs and the front legs. Both are uh, on the left which we are having is for the rear legs. On the right one it is for the front legs. So on the x-axis we are having chalk numbers. And in the given figure, which is sir is pointing now, in the middle section we can see that we are having more variation. So from the that we can inference that the more load will be coming on the middle portion. So these are the conclusion drawn from the investigation. Due to inherent limitation of empirical formulae for design of supports in longwall working, it is essential to adopt observational approaches for evaluation of support support system and modification as per the results of observations. The system of support as designed ever was used along with meticulous monitoring of strata behavior for successful extraction of depillering in various coal mines and used for evaluation of adequacy of support capacity for a typical longwall panel. So this one is the for the reference. continuous monitoring of powered roof supports at longwall phase. This paper describes need for continuous monitoring of powered roof supports at longwall phase and development of an intrinsically safe data logger for continuous monitoring of roof supports at longwall phase. Load and converge. Yes. So, why it is required, we are going to see. We require to monitor support load and phase convergence. There are two crucial parameters for quantifying. First is strata behavior and support performance in a given geomining condition. Uh, so this is the continued part for the last. The compilation of the field data shows that observations are taken manually once in a day or a shift. A manual observation at a moving face is not possible at higher frequency for a meaningful utilization and reference of such field data. So this is the model simulated versus field observed data on a 4 into 760 ton support deployed in panel 21 at PVK 5 mine SCCL. PVK is Padmavati Kani mine. So in the given graph, we can see that means uh, how the means load in increasing with the phase advances. In the initial, we have got the kind of straight graph up to 40, and after that it is increasing from 40. Uh, uh, and we can see from the graph that around 45 there is a main fall, which is a major fall took place, and from there we can see that later it is periodically increasing and decreasing. And with the periodic caving. So this is more. Uh, so this is from the another mine. This is a model simulated versus field observed load on 4 into 360 ton support deployed in panel A4 at what is that mine, sir? Munidi mine BCCL. Uh, BCCL is Bharat Coking Coal Limited. And in this graph we can see that how means the way phase advances, how the load has increased. So around in this one the main fall is which is major failures from between 25 to 30. So this shows that it is the easily capable roof. So from the graph we can see that 20 to 30 meter phase advance was sufficient for caving. And the from yield load was 325 tons. Yeah. Okay, sir. Hmm. So more studies were done, but for today we'll break here. Yes, sir. CP2 was already asked, sir. So why we need setting loads? So now I'm giving your voice to them.
Yes, my beloved students, having a set of interaction inconvenience because of problem in the voice to our MST. We tried our best, communicated to Incharge Dr. B.D. Sahu and our Manas Patnaik and others, including Swine. All are working on this, and these videos are also there with them, and they are exploring why these problems are coming. Now, if we can utilize this time to answer and have an effective interaction, why this CEP question is your continuous evaluation point to discuss, and this helps you and me also for evaluation of your whether it is for midterm purpose, for PMR, for whatever. Of course, now we have decided to hold the exam offline, and all those details will be shared with you to our academic office as we discussed in the next meeting. And accordingly, meanwhile, you can think of this CUP2 and your summary. Just for a minute, I like to slide to say that I hope already you got the message for your coming back to the campus and about the practical examination and also theory examination. If you have any doubts, also you can ask or you can write. I would like to provide some information which will be useful to you people. Now, we are going to our main menu for taking your attendance and also your answer summary. I think now people may stop my voice so that the record will be stopped.
Okay, sir.
Let them answer. And summary. On my behalf, you can answer.
Okay. Anybody interested to answer the CP2 question?
Yes, sir.
Sir Swati.
Gogul Sadiq.
Your name and country.
Sir Gokul Satish.
Hello.
Google.
Yes, sir.
Gokul, answer it.
Yes, sir. The setting load is usually an extra load which is attached or imparted to a already existing prop which is used to support the side wall face. Its purpose is to firmly attach the prop to the ground and also to give resistance when the face machines pass through the face. So the lateral strains will be resisted by adding these setting loads to the props. Also, they help them to stay attached firmly to the ground. So that's the answer.
Swati, if you want to add something, you can add.
Sir, in long wall mining, there is mostly the separation that occurs continuously. So in that case, if we have a setting load, it can determine how the lateral, like we can determine the property of how the support system that we have um, inculcated in our minds is whether firmly attached to it, and whether it can prevent the separation that is occurring, and at the same time it can resist all the lateral stresses that are acting on the seam.
How much should be the setting load? This is not only for Swati, anyone can answer it. So the question is, how much should be the setting load, or what is the percentage?
Hello, sir. It's around 80% of the load capacity, sir.
Okay. Now we are proceeding for summary. Who is interested to summarize? So it's already 11 o'clock. Anyone interested to summarize the today's lecture? So this was the material given to us by Jayantu sir little back. So if any doubt is there, we can refer from here, or either we can ask Jayantu sir on WhatsApp or call. All the different approaches we discussed today is given there. And for any doubts, you can call Jayantu sir or WhatsApp Jayantu sir. Yes. So anybody interested to give the summary? Oh, okay, so all the materials we discussed today, the different approaches and the investigation we saw, these all things are in the material which was sent to us by Jayantu sir. So if anybody is having any trouble, they can refer from here. And still, if they are not able to clear any doubts, they can call sir or text him on WhatsApp. And as you can see here, these are all the references provided here, and and we can see that okay, there are a lot of references from Jayantu sir, like 13, 15, 14, 15, 16. And hmm, and we can see here in 21 and 22nd reference that Kitty and Singh sir and Jayantu sir uh, behavior of seal support during integral caving of thick Thick Sim, a case study. This book is in the library also if you want to refer it. Thick Sim one. Okay, this symposium was held in New Delhi and it is published by Oxford and IBH. And it is from page 573 to 582. So this is the publication from Delhi, but it was held at CMRS. So this book, this text is also so the, so this is available in also in Hindi, promoting our national integration. So this is reference number 23, which we are having Singh TN and Jayantu S, Prashad D, and Singh DP, 1990, published in the year 1994. झरिया कोलांचल में मोटे पर्थों का खनन एंड प्रणाली का विकास. Okay. Proceedings of Sanitary Symposium on Jharia Coalfield from 3rd 4th December 94 from page 170 to 127. Okay, sir. Yes, sir. We are late for the next class. Sir. Oh. Okay, everyone. All the best for to. Yes, sir. Jai Hind, Jai Bharat, Jai NIT Rourkela, Jai Starter Technology. Okay, sir. Thank you, sir. Okay. Okay.
All the best. Jai Hind, Jai Bharat. Sorry for this inconvenience due to FSP problems of audio. And for this class, the call should be transferred to our meeting for giving my voice through him and through his mobile. All the best once again. Jai.
Thank you, sir.